Considering that currently baking within Blender is pretty slow and that displacement can be a bit arduous, having to set up lots of shrink wrap modifiers, plus seeing how it's a simple 2D orthographic perspective that we're trying to achieve, the easiest way to generate the texture maps that we need would be to render from a camera rather than bake out to a plane. Before we actually generate the texture maps that we'll be using later on as usable assets, we've got a little bit of setup to do. By taking a little time to talk about and set up each pass, such as the base color, the normal, and the height map, and so on, we'll find that at the end it'll be really quick and easy to generate all the maps we need in one go. So let's start with one of the simplest to set up, which is the base color. Firstly, notice here I'm using the overridden linked in meshes, and I've created an extra blend file for this. What we're going to be rendering can loosely be separated into this section on the right, which I'll move into a new collection called facade linked _R, which we can now see pop up in the outliner. And if we click on the checkbox there, we can disable and exclude these meshes from the view, and that should make any navigation within the viewport super smooth now, as well as allowing us to focus a little more on what we'll be working on. These meshes on the inside corner will likely come in useful while we work on both main sections. They sort of overlap and are part of the main wall on the right and the main wall with the missing shelter section on the left. So let's press M to move them into a collection called facade linked _C for corner or center, I suppose. That just leaves this section on the left, which I'll rename with an _L at the end, seeing how it's on the left. I'll press the little checkbox again, so that brings back those central overlapping meshes, and then we're ready to just focus on this section on this wooden facade with the missing shelter. Alright, let's head over to the Render Properties tab of the Properties window. Right near the bottom here is the color management. We need to switch from the Filmic default to Standard. By choosing Standard, we're saying we don't want any intelligent and visually appealing scaling of values that we'd get with Filmic in our renders. We need our results to be as predictable as possible. Next, we need to set up the camera. I'll reset its position with Alt-G and its rotation with Alt-R. Then I'll move it out on the Y-axis. Rotate around the X-axis and key in 90 on the numpad there to make it face towards the wall. Let's jump into the camera view with 0 on the numpad, and then press G to move it up towards the center of the wall a little bit more. In the Properties window, let's take a look at the camera settings. When we bake, that's an orthographic render, so we're going to switch that here. We don't want any perspective distortion. Jumping over to the output settings, we can change the aspect ratio of the camera to be square. We can do this by setting the resolution for X and Y to basically the same thing. I'll go with 2048. We can set the percentage beyond 100% if we want. So for example, we can get a 4096 render by keying in 200% here. With that done, let's go over to the orthographic scale in the camera settings and set that to cover a distance that we want to include. Mostly we'll probably be rendering out between the 2 and 4 meters range. Somewhere around 2.5 is fine for now. After lining up the position a little more, I'd like to reduce the amount that we can actually see outside of the camera frame. That can be done with the viewport opacity 2 setting. So I'll take that pretty high to something like 0.9, if not all the way to black. Sometimes seeing outside the frame can be a little bit distracting. Alright, while we can certainly render some passes from Eevee, the most accurate renders we'll be getting from Cycles. So next I'll switch over to Cycles and choose GPU as the device, as it's usually faster. However, we're going to see in a moment that we'll be instead switching to CPU, as depending on your GPU, you might not be able to squeeze this amount of data into it. Another consideration for our renders is how many samples we'll need. This can be very low, so we'll set it to about 4 for now. Normally the amount of samples would help to reduce the noise in an image caused by, say, the lighting or maybe the depth of field. However, we're not using lighting in these particular bakes, so really the only reason we need our samples is so that the pixel filtering can do its job. And at around 4, that's about as low as we should go for now. Ideally more like 8 or 16 for final renders. Here I've rendered the camera view out with different amounts of samples. This first example is just one sample. To see the differences here, we're really going to need to zoom right in. The area where we're most likely to spot the differences is probably around this pretty high contrast area here. At one sample, it's a little bit jagged looking. Here's the same image rendered with 4 samples. Now I'll toggle between them so that you can get a good feel for the differences there. Next up, I've got the same image but with 8 samples. I think the difference here is getting less noticeable. It is improved with 8 samples, but again, this is getting more subtle. I'll toggle between them again to give everyone a chance to catch the slight difference. Next, I've got an image with 16 samples. Again, this is even more subtle. In some images, perhaps this would be more noticeable than it is actually here, but I think we're unlikely to need more than 16. Next, I'll middle click and rotate outside of the camera view so that we can see the render distance. Using 7 on the numpad, I'll take a look from top view and go over to the camera settings to enable the limits in the viewport display section. Using our clip start and end settings, we can see these limits to start just before the geometry we want to render and just after. This should help speed things up a little bit more and also help with any resulting cleanup by not having to render stuff in the background or much further in the foreground than we actually want on our final renders. Between 2.4 and 3 meters looks about right. Next, I'll jump into the shading workspace and give it a second while the vertex colors load. Perhaps the easiest way to get our base color pass would be to simply Control-Shift-Click on our vertex color node. Thanks to the Node Wrangler add-on that we've got enabled, that will automatically hook that up to a temporary emission shader, meaning that if we render now, we won't be affected by any lighting, just the info we need to plug into our base color socket of the principal shader. Though that's not especially convenient having to alter the shader in the shader editor, as we know we'll be needing multiple passes down the line. It'd be better if it was just available as another pass in the compositor. Another option we have in this case is we can simply enable the diffuse color pass. Then if we jump over to the compositing workspace, we can enable the use nodes option at the top, and then on the render layer node, we'll see that there is an output called diffcol. I'll just rearrange these windows a little as we don't need the timeline, so I'll left click and drag from the lower right corner of the compositor window into the timeline to collapse it. And to get the maximum space here, I'll press N to close the sidebar. It'd be handy to have a 3D view to look at here as well, so within the compositor window, I'll left click and drag from the top left to the right to split the view, and I'll change the one on the left to a 3D view, looking through the camera with 0 on the numpad. I can then middle click and drag across the options at the top of the viewport there to slide them across so that we can see the render options and switch over to the material preview viewport mode. We could have just used the shortcut Z for that, but I'd just like to be able to see those there so I can confirm what render mode we're in just at a glance. Let's try rendering from the camera now. To do this, I'll go to the render menu and then choose to render image. We could also just have pressed F12 as the shortcut too, by the way. The first time you render, it might take a while to put everything into memory, but for me, after about a minute and a half, my GPU basically just gives up on me. As we can see from the warning at the bottom in red there, that reads, "System is out of GPU and shared host memory." So I'll press escape to close that and then switch from GPU to CPU and try rendering again. After about a minute, we've got what we need. To see the render pass in the window here, we need to switch from composite to view layer and then choose the diffcol pass from the pull down menu. Everything is looking great, but there's a couple of things we might want to improve, and that's this black hole of no data that we have in these sections. It'd be good if rather than being black, that registered as transparent. To do that, let's jump back to the previous window, and in the film settings, let's set that to transparent. While we're testing things and still setting up, I'll reduce down to just 100%. So we're getting a 2K image instead of the 4K image before. Then when pressing F12 to render, it should be a little bit quicker, but also we should see the checkerboard showing up so that we have transparency in our render now. But if we take a look at our diffcol output, it looks like we don't have that transparency anymore. So what we need to do here is to combine our alpha output with the diffcol output. We can do that with the set alpha node. Hooking that up to the composite output should mean that we'll be in the main render the next time we hit F12. We can also get a preview of our changes here in the backdrop of the compositor, though if we Control-Shift-Click on the set alpha node, we'll also create a viewer node and see the image behind our nodes. I like to press V and Alt-V to zoom in and out to this image, and we can clearly see now that we have transparency in our diffcol pass. The thing is, we actually don't want any transparency in our passes. We want to fill in these areas with a pixel value that matches the border of these gaps. This is basically what's happening when we bake. We can actually see we have a margin option with the bake settings. The reason we have this is basically to avoid mip-mapping issues. To give a little more of an idea on what we're talking about here, I've jumped into a super simple cube scene. We can see the lower left, we can see the UVs of our cube in front of the image that we're going to bake onto. Here I'm just using a white emission shader, so I'm going to bake the emit pass, and we're set to 0 pixels in the margin. The bake image is already selected in the shader editor, so I can just press bake to render this out. In edit mode, we can really see the white goes right up to the UV borders, but no further. If we plug this into the emission color socket, we'll then see the result on the cube in the viewport. Zooming right in and making the view a little larger with control space, we can see there is a slight black edge at the borders of some of the UVs. This is our MIP mapping issue, and it can sometimes become larger problems when zoomed out. However, for this case, this is probably a very forgiving case. All the UVs are perfectly straight and it's a pretty simple bake. But even here we're getting that slight black line. That's what our bake margin is going to be for, to completely fix the problem. We just need to increase to about 2 pixels as a margin here. And then if I unhook the image node from the emission shader so that I can bake again, we can see now the white goes beyond the UV edges. And in the 3D view, we've got absolutely no issues whatsoever now in this example. If we want to replicate this within the render, we need to use an in-paint node and drop it in after the set alpha node. So we need our transparency, but only so that the in-paint node can do the work of a margin bleed sort of effect that we would use when baking. As we increase the distance value here, we'll see the same effect that we get from the bake margin, except as a bonus here, if for any reason we wanted to, we can still adjust it after the render. Switching over to just see the alpha channel should show us if we've completely closed the gaps or not. And it looks like there's a little bit left. So I'll take that to 115 where it completely closes up, and then switch back over to see all of the image channels. So that does look good, but if we look closely, we'll see that the values that are being in-painted there are slightly darker. Since this is overall only quite a slight change in value, probably this isn't really going to create any issue for us with MIP mapping. But it would be nice to improve and at the very least understand what's going on. So the reason we're getting this darkening here has to do with Blender's pixel filtering that can be found under the film setting. If I change the Blackman-Harris filtering to as low as it'll go at 0.01 pixels and then press F11 to get our previous render back, we can set ourselves up to use slot 2 so that we can compare the changes easily. Then I'll press F12 to render into that new slot. Pressing 1 and 2 above the QWERTY keyboard allows us to toggle between the render slots really easily. Unfortunately, after the changes made earlier, I don't think I re-rendered, so we'll need to switch over to slot 1 and then change the filter back to 1.5 and then render again with F12. Then, when we use 1 and 2 to switch between the render slots, we can clearly see how much darker the filtered version becomes. This can't really be considered a fix for the problem though, because now we're not getting the benefits of the pixel filtering. The image becomes much more jagged and aliased basically when compared to the filtered version. We'll get far more undesirable artifacts in the image without the filter. To solve this, rather than using the very edge pixel to in-paint with, we'll use the pixel further from the edge. For that, we'll use a dilate and erode node on the alpha channel. Setting it to -1 should be all we need to do. However, rather than using this like a mask, we need to simply switch to the replace the alpha option within the set alpha node. Now with a setting of -1, we should get that bake bleed margin we've been looking for without the considerable change in value. Earlier we enabled the diffuse color pass to show up in the render settings. There's actually another option for us to get our base color pass while keeping all of our passes organized within the shader itself. So to wrap up this base color chapter, let's make that change. The first thing we need to do is to add a shader AOV. AOV meaning arbitrary output value. Incidentally, rather than it simply being good for keeping them organized and all grouped in the shader, actually some of the passes are going to demand we use AOVs anyway, as they're not going to be available elsewhere by default. We're going to need the shader editor in a moment, so I'll jump back over to that workspace. And to add a shader AOV, I can just go to the bottom of the View Layer Properties tab of the Properties window and then click the plus to add an AOV. And then double click on the name to rename it to something more descriptive like BaseColor. And this is a color output, so we can leave it as that. And then all we need to do is add the AOV output within the shader editor. And now we can hook what we've got going into our main shader, also into the AOV color input. Finally, we just need to give this a name to tell Blender which AOV we're talking about. It's fairly easy at the moment as we only have one, but here we would write it exactly as we wrote it in the properties window. So BaseColor with a capital B and C. Switching over to the compositor workspace, we'll see the BaseColor AOV show up in the render layer node. So we can now hook that up to the set alpha node instead of the diff call pass. We haven't rendered it yet, which is why it's still black. Then going to the render layers, we can disable the color pass of the diffuse section as we no longer need it. That's just basically a duplication of our AOV that we've just set up, except for having to save it out manually. This is no big deal for just one pass. However, for multiple passes, it's going to be nice for them all to save automatically. And for this, we can use a file output node in the compositor. So let's go Shift A to add in a file output node and hook it up. With the node selected, we can press N to open the sidebar and take a look at the properties. This is where we can choose the file type we want to save as, which for BaseColor will be TIFF. We'll not be saving the alpha channel, so just RGB is fine. And we don't need any more than 8-bit for the BaseColor either. The name of the file I'll call BaseColor, though typically we'd want to call it something like wood facade _BC perhaps. Taking a look at the node itself, we can see on it the name of what the file will be and the file type. Another general workflow tip is that it's usually a pretty good idea to mute these output nodes with the M key right up until the moment you're actually going to render. Just in case you're changing something in the scene, hit render to see the results and forget that the file output node is unmuted, as we'll actually be saving that file to disk, or in fact overwrite an existing file we might have wanted to keep. Finally, let's do a test render. I'll give us a bit more room by closing the sidebar with the N key. I'll unmute the file output with the M key, and then click on the little folder icon to set the folder. I'll use the same folder as these other test renders. Then when we press F12 to render, we'll wait for that spirally goodness to unfurl, and then we no longer need to then save the file manually. The file output node will do that for us automatically. So we can just double check that by clicking on the folder icon again, and we'll see there's our new image BaseColor 0007.tiff. The reason for that 7 is because we're on frame 7, which we can see up in the top left of the 3D view. So to go back to frame 1, we can just shift and left arrow. The next time we render, we'll have a 000 and then a 1 instead. So that wraps us up here for the BaseColor. In the next chapter, we'll see how learning how to set the AOV up helps us, as we'll add a normal map as an additional render pass. And then beyond that, we'll add more passes that we'll be able to then use as a kind of template for future renders.